all fine, it seems all fine, but we haven't actually measured anything here. I don't know if you can see in the camera that it seems that there are some slight differences here in the two waveforms. These are two waveforms, one upon the other, and you might be able to see slight differences there. They might not be real. They depend on the sampling of the scope, I guess. So in order to do a more precise, in order to have a more precise view of what's happening, I will switch to the FFT. I have already saved the settings for the FFT. Now this is the FFT. In the you see here the channel 1 and here the channel 2. And the FFT function that is now selected is the subtract. So you actually subtract one waveform from the other. If these two waveforms are the same amplitude and the phase, then the result will be no waveform at all, a zero amplitude signal. And this is actually what we see there, a zero amplitude signal. Now if I disconnect one of the two signals, you will see a waveform. This is our waveform. 30 megahertz, and then I connect this again, and then I disconnect the other waveform, again our signal 30 megahertz. So it seems that the splitter works quite well. I will change the frequencies a bit. Now we are at 30 megahertz. Now we are at 22 megahertz. Now this is 13 megahertz. This is 10 megahertz. This is 7 megahertz. And this is 4 megahertz. Switching back to 28 megahertz, so you can see something I want to show you. You see here that there is still some very low amplitude sine wave, and let me show you how small it is. If I disconnect one of the channels, you will see the real amplitude out of one of the outputs of the splitter. So this is the real amplitude, and this is the amplitude after subtracting the two outputs of the splitter. So yes, there are some imperfections, of course, in the output level, but you know, some differences in the outputs level, but in general it seems that the splitter that we have built works successfully for all HF frequencies. Here is the same waveform at about 30 megahertz, and you can see that I have set the sensitivity of the scope to the maximum, 25 millivolts per division. So this waveform is about a division, so it shows about 25 millivolts of difference between the two signals. However, this might not be actually the amplitude difference, but tiny variations in the phase difference between the two signals that may have been introduced either by the splitter or by the slightly different cable lengths. I've said at the beginning that I have put two equally lengths of cables, but I have actually have different connectors in the cables, and one of these cables is using a small adapter. It's composed of two smaller pieces of cable, and also there are differences in the end connectors. So all this might introduce some phase or even some amplitude difference depending on the loss of these things. But 25 millivolts difference is quite small difference for most of our QRP projects. An interesting thing is that when I connect the two cables together,